All circles are similar. Why? Because by the definition of similarity, which is the same shape, proportional size, or angle, we can notice that all circles add up to 360. And the only variant is the radius, which is this part. And there are no variety of circles like triangles, isosceles, equilateral, or scaling, making all circles the same shape. So this means that all circles are similar. Relationships between inscribed radii and chords. So this is an inscribed angle and this is a central angle. So you can see that it has the inscribed angle is formed with two chords that make up the angle A. This is the equation for it. That means a half times angle B. So A is an inscribed angle, B is the central angle. In this picture, PQR is the inscribed angle, and it doesn't have a central angle. And the inscribed angle is formed with the two chords. In this one, the inscribed angle have a central angle and two chords. It also have these two angles that show that they are congruent, 2A and A. And this one, the inscribed angle has two chords and also the central angle that is 0. So this is the relationship between inscribed angle with chords.
Okay, so what is a tangent? A tangent is basically a line which passes through the circumference of a circle, only touching it once. So it's perpendicular to the radius. So here we have a clear example of a tangent. It's marked red. We have the diameter here, which is, the size of a radius. We know, it's marked as a perpendicular angle, as shown here. And now, I want to give you like quick 3 examples, so you can try it on your own. Tell us which colored line is a tangent and why. Basically, for number 1, the green line, because it's perpendicular to it as to the diameter, as we can see here by the symbol, and it's only crossing one line. Here, it's perpendicular to the radius again. It's not shown, but we can assume it because also the fact that it's just crossing one point in the circle. Finally, this is the second easiest one. Basically, it's the blue line because it's perpendicular to the radius and it's just touching one point.
Okay, relationship between central, inscribed, and circumscribed angle. Here we have a circle with the inscribed central and then circumscribed angles. The inscribed angle is made by two chords, meanwhile the central angle is made by two radii. And then finally the circumscribed angle is made by two tangents. What is the relationship between the three of them? It's pretty simple. The inscribed angle is always half of what the value of the central angle is. And the central angle and the circumscribed angle are supplementary. They add up to 180. Now to solve this circle up, we know that the inscribed angle will be half of the value of the central angle, which is 134, meaning the inscribed angle is equal to 67. And the circumscribed angle must, together with the central angle, add up to 180, meaning that the circumscribed angle must be 46 degrees. So now I want you to try some exercises by yourself. I want you to find x and y for each of these exercises right here we got in your phone. You will have about 30 seconds. Okay, so basically we know that in number 1 that the central angle and or the circumscribed angle, they add up to 180. So 140 plus x should equal 180, and so 40 is the answer. For number 2, we must find the central and the circumscribed angle. We have the inscribed angle. We know that the inscribed angle is always half of the central angle. So by following that law, if we do 50 times 2, we get 100, which would be equal to x, given that's the central angle. And because x and y are supplementary, 100 plus y, which would be 80, is equal to 180, making y equals 180. Now, finally, for the last part, we have to find y, which is the inscribed angle, and x, the circumscribed angle, and we're given the central angle. This time, we must find the half of 125, which would be equal to 62.5, giving us the inscribed angle. Once we got that, we know that 125 plus x is equal to 180, and we know that 55 plus 25 is equal to 180, making x 55.